Lesson: Future Directions in Intrusion Detection Systems. Future directions in intrusion detection systems are increasingly being shaped by advancements in artificial intelligence. Traditional IDS methods are becoming less effective in the face of evolving cyber threats, necessitating more sophisticated and adaptive approaches. AI-enhanced IDS is emerging as a powerful solution capable of addressing the dynamic nature of cyber threats through advanced techniques such as machine learning, deep learning, and reinforcement learning. These methods provide the ability to detect novel and sophisticated attacks that traditional signature-based and anomaly-based IDS struggle to identify. One of the significant future directions in AI for IDS is the integration of machine learning algorithms. Machine learning can enhance IDS by enabling systems to learn from historical data and improve their detection capabilities over time. Supervised learning algorithms, for instance, can be trained using labeled datasets of known attacks and benign activities to build models that can classify incoming network traffic as either malicious or benign. These models can then be continuously updated with new data, allowing the IDS to adapt to new types of attacks as they emerge. For example, support vector machines and random forests have shown promise in accurately classifying network intrusions. Deep learning, a subset of machine learning, is also making significant strides in the field of IDS. Deep learning models, such as convolutional neural networks and recurrent neural networks, can automatically extract and learn features from raw data, leading to more accurate detection of complex attack patterns. These models can handle large volumes of data and identify intricate relationships that may not be apparent with traditional methods. For instance, a study demonstrated that a deep learning-based IDS outperformed traditional IDS in detecting various types of attacks, including denial of service and probing attacks, with higher accuracy and lower false positive rates. Another promising direction is the application of reinforcement learning in IDS. Reinforcement learning algorithms can learn optimal policies for detecting and responding to attacks by interacting with the environment and receiving feedback in the form of rewards or penalties. This approach is particularly useful in dynamic and complex environments where the nature of attacks and normal behavior can change rapidly. Reinforcement learning can enable IDS to not only detect intrusions, but also take proactive measures to mitigate them. For example, an IDS using reinforcement learning can learn to prioritize the most critical alerts and allocate resources to address them effectively. AI-enhanced IDS can also benefit from the incorporation of ensemble learning techniques, which combine multiple machine learning models to improve overall detection performance. Ensemble methods, such as bagging and boosting, can reduce the likelihood of false positives and false negatives by aggregating the predictions of several base models. This approach can enhance the robustness and reliability of IDS, making it more resilient to adversarial attacks and evasion techniques. For instance, an ensemble of decision trees and neural networks can provide complementary strengths, leading to better detection accuracy. The use of AI in IDS is not without challenges. One of the main issues is the availability and quality of labeled data for training machine learning models. In many cases, obtaining labeled datasets that accurately represent the diversity of network traffic and attack patterns can be difficult. This limitation can be addressed by using semi-supervised and unsupervised learning techniques, which can leverage both labeled and unlabeled data to improve model performance. Additionally, the deployment of AI-enhanced IDS requires significant computational resources, which can be a barrier for organizations with limited infrastructure. However, the advent of cloud computing and edge computing technologies is helping to mitigate this challenge by providing scalable and cost-effective solutions for deploying AI models. Another critical aspect of future IDS research is the exploration of explainable AI to enhance the transparency and interpretability of detection models. One of the criticisms of AI-enhanced IDS is the black box nature of many machine learning algorithms, which can make it challenging to understand and trust their decisions. Explainable AI aims to address this issue by providing insights into how models make their predictions, enabling security analysts to verify and validate the results. For example, techniques such as feature importance analysis and model visualization can help to elucidate the decision-making process of deep learning models, making it easier to identify potential biases and errors. Incorporating threat intelligence into AI-enhanced IDS is another future direction that holds significant potential. Threat intelligence provides contextual information about known threats, such as indicators of compromise in tactics, techniques, and procedures used by attackers. By integrating threat intelligence feeds into IDS, AI models can be trained to recognize and respond to specific threat patterns more effectively. For instance, incorporating real-time threat intelligence can enable IDS to detect advanced persistent threats and zero-day exploits that may not be identifiable through traditional signature-based methods. Furthermore, the development of collaborative and federated learning approaches can enhance the effectiveness of AI-enhanced IDS. Collaborative learning involves sharing knowledge and insights across multiple organizations to improve collective security. Federated learning specifically allows multiple institutions to train AI models on their local data while sharing only model updates rather than raw data, preserving privacy and confidentiality. This approach can lead to more robust and generalized models that can detect a broader range of threats across different environments. In summary, the future directions in IDS are heavily influenced by advancements in AI, with machine learning, deep learning, reinforcement learning, and ensemble learning playing pivotal roles in enhancing detection capabilities. Despite challenges such as data availability and computational requirements, the integration of explainable AI, threat intelligence, and collaborative learning approaches offers promising solutions. As the cybersecurity landscape continues to evolve, AI-enhanced IDS will be crucial in providing adaptive, accurate, and proactive defense mechanisms against sophisticated cyber threats.